In this video, I'm going to explain something I think we've talked about before, but it's good to have a review of. And that's what happens if we store a raw pointer or some kind of memory entity as a member data in our classes. Okay. And this to do this correctly, we have to apply what's called the rule of three. So the rule of three has three functions that we have to make sure are in our program. Okay. So, and the reason that we do this is that we want to make sure that we're allocating the memory properly and then we're freeing it also. Okay. The other issue that we have to deal with here is the deep and shallow copies. Okay. So a shallow copy is something we sometimes call aliasing. And aliasing, you've probably heard me rant about it before, basically means you have two names for the same spot in memory. Okay, so if we don't do the rule of three, if we have a stack S1, a stack S2, we say S1 is equal to S2, we don't have two stacks. We have two names for the same stack, which leads to unpredictable results. You change one, you change the other. That's not what we expect. Okay. So this comes up for us in adding a dynamic array to our to our stack implemented using arrays. Okay, so when we add that pointer in there, and this is kind of an example of what that looks like. So here we have our stack class, and here we have our dynamic array. Okay, so we're going to be able to set the capacity when we start. Okay. In this particular example, I added a capacity for a max size. The problem didn't say to do that. You don't have to do that, but that's something you can do if for some reason you want to limit the size. Okay. So again, this pointer, whenever you see a star in your data for your class and your private data or public data for that matter, but it's typically going to be private, you have to work on these things. Okay. Again, we'll go through these one at a time. And again, there's our stack top. Okay. So in our constructor, again, because this is dynamic, we're going to send along the capacity, okay? And I think our problem said to make the capacity equal to 100 by default, so we can do that there, okay? Then if you have the capacity, which if you don't, you don't have to worry about, but I have that capacity integer. I'm going to set that to the cap that I'm sending in. I'm always with a stack, setting the stack top equal to -1 to denote that it's an empty stack. And then I'm allocating the new memory here, okay, on that capacity. If you were not using this capacity variable, we would just have our stack top equal -1. We would allocate memory here just to the variable that we're sending in. Again, with 100 as the default. Okay. So here's the first thing that we need. We need a destructor for the stack. Okay. And the destructor is going to delete all of the memory items that we have, whether it's pointers or arrays or whatever, dynamic arrays or whatever. Okay. So in this case, we're doing the delete. Remember, if it's an array, not just a pointer, we have to put the square brackets there. We're deleting our array. Okay. The next thing we have to do in the rule of three is this copy constructor. So a copy constructor kicks in if we want to create, in this instance, a new stack S2 that's exactly like S1. Okay. As we talk more about stacks, it will become clear that anything we do with a stack, a search, a print, anything, is destructive to the stack. It has to wipe out the stack to do it. Okay. So therefore, before we do any of those operations, we'd better make a copy and work on the copy. Okay. So if we were not to have a copy constructor or the overloading of the equality sign, then printing out an array, even if we make a copy, would delete the array. Okay. So in this case, we can create a new stack S2 equal to S1. Then it's new and it looks exactly the same. Okay. So this is what it looks like here. We have stack, and then we have this constant stack ampersand other. So the other stack coming in. Okay. This should not be your only constructor because you're not only doing a copy constructor. You should also have the constructor that we had up here, the normal constructor with the capacity. Okay. So for this one, we're going to start by copying over the basic values. Okay. So the other is the one we're passing in. It's on the right of the equal sign. So the other is the S1. That's the one that you're copying from. S2 we're copying too. Okay, so capacity refers to S2, other refers to S1. Okay, so we're saying the capacity for our new stack is equal to the capacity for the other stack. Okay, same thing for the stack top. We're setting those. Whatever those are, we're setting those exactly the same. Okay. We now have to, we can't just copy the array directly. We have to go element by element, or we're going to still have an alias. So we're going to create this array variable here is equal to new int capacity. Okay. So that's a new array that we're creating. And then we're going to go through from 0 up to the stack top. Okay. And we're then going to set the array position equal to the other array position. Okay. And then the last thing we have to add is the copy assignment. Again, we want a deep copy, not a shallow copy, which means we're making two distinct structures in memory, each with their own name. So in this case, both S1 and S2 are both stacks. Okay, so we can say S1 equal S2. Okay, so again, in this case, the other, okay, is going to be the one. So we're saying S1 is getting the value of S2. So again, S2 is going to be the other in this case. And it is kind of the opposite of our other example. Okay, S1 will be the regular variables. Okay. So the first thing we want to do here, just for efficiency, we're going to say if this does not equal to the address of other. That prevents a self-copy. If S1 is S2, there's no reason to copy it. Okay. If not, we're going to delete. Okay. We're deleting. So when we say S1 equal S2, we're going to delete S1. Okay. Then we're going to replace it with S2. We delete it here. We set, as we did before, the capacity in the stack top equal to the other. Okay. We then reallocate on the new capacity because there's a possibility that there may be a different capacity between the two stacks that we're copying. Okay. So we have to make sure we set that properly. We're then going to go through as we did before, item by item, okay, until we fill the new array with information from the old array, okay? And then we return a pointer to this because the equal sign wants a pointer back to the one you've copied, okay? Okay. So if you add those things, then that is going to be, that's what you need to do every time we have this. Will it work? Will it compile and run without the rule of three? It will, but there will be situations in running the code that are not going to do what you want them to do. Okay. And that's really what it comes down to. Okay. So I just wanted to point out also that I've added a tutorial. So let me point to this one. I've added a bunch of tutorials, and they're at the top. We're on Canvas here. In the general class information, there's a bunch of stuff, okay? That could be videos. So, for example, here I've got the video on dealing with segmentation faults, okay? And then I've got other tutorials such as using linked lists in C++, debugging programs. I've added this linked list cheat sheet when you're dealing with linked list. It has some of the basic operations that we do. Just, I found myself needing this when I was working through programs. So I put it out there for you as well. Okay. Um, so all of that is available at the top. But the newest things I've added, static variables we talked about in class. So there's a little handout on static variables. Okay. That's there. Okay, so you can go through that. Most of these, again, with the tutorials, I start with asking ChatGPT to create a tutorial. I then go through and rigorously edit it to make sure that it's correct and not hallucinating and that it says what I want it to say. Okay, so that's how that works. And then the in-class policy I mentioned before, but I'll mention it once again because why not? The in-class are designed to be done with you physically sitting in the room. Okay, so if you're not sitting in the room, then we have kind of an issue. If you're sick but feel well enough to Zoom, then that's okay. On occasion, we can do that. Okay, but you have to let me know in advance so I can set up the Zoom. Okay, if you don't feel like Zooming and you're sick, we'll work something else out. Okay, what you can't do is just on your own uh, do the in class at whatever point without consulting me first. Okay. So the other thing we have to deal with here is that I've seen some of you in section two when the section one class starts at 9 o'clock, you'll jump on and start working on the in class. Okay. And that really is a disadvantage or an advantage you're taking in that you have a longer amount of time to get the work done. So the section one class has from 9 till 9:50 to get done. And you basically have from 9:50 to 11:50 to get done. Okay, so that's not fair. So so don't do that. Don't look at it in advance. Okay. A couple of things I can do. There may be a way in Canvas I can set that up. I'll look at that for sure. But the other thing I can do, I can look to see if you're on the server working on those programs at that time, or I can also look to see when your file was created. And if those were created early and you weren't in that section, then I'm going to give you a 0 for that assignment. Okay. Um, I will say for both sections, if you ever need to attend the other class, it's not really a problem. Section two is a little more full than section one, but it's not a big deal. So if you ever have a conflict and want to attend the other one, okay, that's fine. Okay. And then if you're sick, you can always Zoom if you're feeling up to that. Okay. Or if you have to be away for whatever reason, we can try to work it out. Okay. But the reason we went here, so let's not lose ourselves in that, is that what we just talked about, this dealing with raw pointers, there's a tutorial out there that I've put that kind of goes over what we just went. Okay. And this you can go through as you're working on um, the homework that's due tomorrow on adding the dynamic. Okay. So if you have questions on any of this, either text me today or we will talk about it tomorrow in class.